Chapter 3 Border Control. Let the flowers bloom. Chairman Mao. Introduction. Before we get into details for this border controller, we start with the concept for network protocol stack. One network protocol B might be encapsulated by another network protocol A. Usually, we say the term B over A to stand for the case that protocol B is encapsulated by protocol A. For example, voice over IP means voice protocols are carried by IP protocol. The diagram above indicates some of the network protocol hierarchy in some applications. TCP, Transmission Control Protocol, and UDP are based on IP. In other words, the two protocols are encapsulated by IP packets. And IP packets might be placed into Ethernet payload or else as indicated in the diagrams above. Further, there might be some other protocols that are based on TCP or UDP. For example, HTTP is usually implemented on TCP. To get what is inside HTTP, it is needed to open the IP packet first. From the header of IP packets, there is a field for IP address. Sometimes, the higher layer of protocols might also put the information of IP address into their data payload to indicate where the data originally comes from. It shall be noticed that sometimes the IP address from the IP header might be different from what it is described in higher layer of protocols, like HTTP, because of some manipulation during transmission. And this is what we are going to introduce. The term firewall or border control here in this system is to handle the checking or manipulation on the network packets on TCP/UDP/IP layers. For TCP or UDP, it is only up to the traffic associated with the logic port, S, that should be accepted, redirected, dropped, or forwarded. For some other functionalities regarding to the processing logic of higher layers of protocols, they have been handled in specific applications themselves. The basic functionalities of the firewall described here are: it blocks the traffic initiated from the hosts outside the firewall to enter the network it protects. It needs to be clarified a little bit: if all the traffic from outside hosts is blocked, how do the people inside the firewall view the web pages on the hosts outside the firewall? For the outgoing traffic from the hosts inside the firewall to the hosts outside the firewall will not block this kind of traffic. Furthermore, those response or reply packets from those outside hosts will not be blocked in response to those original requests from the hosts inside the firewall. However, how does the firewall know what kind of packets are response? The details are out of the scope of this document. It is roughly determined by some characteristics of the network protocols, like sequence number, sender or receiver, or the previous states kept in the firewall. Another function of the firewall is, it is with NAT, network address translation or network port address translation. Basically, it allows the hosts inside the firewall sharing one public IP address by hiding their private IP addresses being used inside firewall. Public IP address public network firewall with NAT, network address translation, private network private IP addresses. For those functions described above, you do not have to set the rules in the web interface of the firewall to perform the desired functions above, they are set already. And those rules will not be seen via web interface, they are considered to exist from the very beginning when you try to add the other rules into the firewall. The following sections will introduce how we add other rules into the firewall for other functionalities. Azblink software components are using the following ports for web-based applications: TCP 8083, TCP 8082, TCP 8081, webmail, it only exists in VED build, and the following ports for VPN: UDP 1194, OpenVPN, UDP 7777, Site-to-Site VPN, and UDP 4569, IAX2 for VoIP. Port forwarding. Port forwarding can be configured via border connection port forwarding, or through the DNAT function add border rule add rule. Conceptually, port forwarding is to forward the traffic arriving at a specific port of the firewall to another server that is inside the firewall. And the corresponding server inside the firewall processes the request and returns the response to the host that sends out the request. Take HTTP and HTTPS traffic as an example, they are of TCP port 80 and 443 respectively. If we activate port forwarding at firewall to forward all the traffic of TCP port 80 and 443 to an internal server A, the server A will handle all the request of TCP port 80 and 443 and entertains the HTTP and HTTPS traffic by sending the corresponding HTML pages back to where HTTP or HTTPS request is issued. The operation principle of port forwarding is, the firewall will perform DNAT, destination network address translation, on the incoming traffic for the associated port, S, by replacing the original destination IP address to new destination IP address in IP header of each packet. So, the traffic arriving at a specific port of firewall will be forwarded to an internal server. When the internal server processes this forwarded request, the return response from the internal server to the outside host will be passing firewall at first. The firewall will perform SNAT, source network address translation, on each outgoing packet on Internet Interface Eth0 by replacing the source IP address in the IP header. Please notice that you do not have to explicitly specify any SNAT rules to change source IP address. The firewall will take care of that automatically by replacing each outgoing packets with its IP address of Internet Interface Eth0. And it will keep its own mapping while some response packets back by directing them to the original sender. The configuration screen here allows you to forward HTTP and HTTPS traffic, TCP port 80 and 443 respectively, by specifying the IP address of an internal server only. For the other types of traffic, you need to identify if it is TCP or UDP and the corresponding ports. Port forwarding enables the possibility to alleviate the processing load into different internal servers according to its TCP port or UDP port. Thus, part of the processing load can be distributed into other hosts. Let's use a simple example to explain how to use this feature. Assume the firewall with public IP address 1.2.3.4 on its Internet Interface Eth0 and private IP address 192.168.2.1 on its LAN interface Eth1. There is another server 192.168.2.21 inside the firewall. What we are trying to do is, if there is an HTTP request coming from Internet side with destination IP 1.2.3.4, we would like use the server 192.168.2.21 to handle the HTTP traffic, TCP port 80, arriving at the IP address 1.2.3.4. In this case, we only need to use port forwarding by specifying internal server's IP address 192.168.2.21 so that this internal server will handle this type of traffic. However, once you do that, all the HTTP requests originated outside firewall with destination IP address 1.2.3.4 will be forwarded into the internal server. That means all the HTTP users outside the firewall cannot access the HTML pages located on the firewall. The HTML pages they actually have seen are located in the internal server with IP address 192.168.2.21. The description above is for the viewers outside the firewall. If viewers inside the firewall, the best way to access HTML pages on the firewall is to use IP address 192.168.2.1, which is the IP address of LAN interface of the firewall. What if the users in LAN are using the IP address 1.2.3.4 for their HTTP requests? The answer is, if the feature designated as LAN net loopback in the following section is not turned on, they will get the HTML pages on firewall without being forwarded to the other server. However, for simplicity's sake, it is suggested using IP address of LAN interface to avoid confusion for the admin users inside firewall to configure the firewall. Another important characteristic of all the port forwarding feature you should notice, on some firewalls, in the IP header of forwarded packets from the firewalls, the source IP address will be labeled as the IP address of LAN interface of the firewall even though the packets are originated from outside and forwarded by the firewall. So, the internal server will not be able to know the packets are from outside in IP layer. The good thing for this is that you do not have to worry about the route for the response packets. For the firewalls without this, you have to make sure the response packets will go back to the firewall performing the port forwarding by checking the routing table on that internal server. For example, in the diagram above, host D outside firewall sends packets to firewall and the firewall forwards the traffic to an internal server A. From A, the source IP address of IP header in those forwarded packets will be shown as 192.168.2.1 automatically. This is to enforce that the returned packets from A will go from firewall back to the outside host D. So, once you open the ports on firewall and forward the associating traffic to an internal server, the firewall will conceal all the information from IP layer. If you want to add more protection on A for this kind of traffic, the logic has to be done in application layer. Request loopback from LAN side, this function only exists in VED build, while port forwarding is set to go in the previous configuration screen, the firewall forwards the traffic from outside to an internal server located inside firewall. But for the traffic originated from the other hosts in the same subnet of that internal server, if the IP address of Eth0 of firewall is used, the firewall will not forward this kind of traffic to the internal server even if port forwarding is turned on. If you want loopback traffic originating inside the firewall is forwarded to the internal server as previous described, you should come to this configuration menu. Let's continue the scenario described above. A firewall with public IP address 1.2.3.4 on its Internet Interface Eth0, and private IP address 192.168.1.1 on its LAN interface Eth1. There is another server with IP address 192.168.1.21 and it is located inside the firewall. Assume port forwarding is turned on to forward the traffic arriving at Eth0 with destination IP 1.2.3.4 and TCP port 80 to 192.168.1.21. Let's consider a further step. What if a PC, with IP address 192.168.1.100, inside the firewall is trying to use http://1.2.3.4, Does the PC user actually see the HTML pages located on 1.2.3.4 or 192.168.1.21? For the PC stations outside the firewall, we have no question about that. The HTML pages on 192.168.1.21 will be seen. That is what port forwarding is designed for. But this case is that the user is inside the firewall. If you want http://1.2.3.4 to be forwarded to 192.168.1.21 for users inside the firewall, then LANnet feature shall be specified along with port forwarding. To let this LANnet loopback feature put into effect, you need to reboot the host after the configuration setting is done. And it is reminded that this feature has to be used with port forwarding together. Example, port forwarding and loopback. Let's use an example on how to configure the system we mentioned above. The diagram below shows the traffic to the port 80 on the outside interface of the firewall will be forwarded into an internal server with IP address 192.168.2.21. The local network is 192.168.2.0/24, it means every machine is with the IP address like 192.168.2*. If you only want to forward the traffic for TCP port 80, navigate via border connection port forwarding, you can set firewall forwarding port number, 80 protocol, TCP forwarding target IP address, 192.168.1.21 and press submit button. And let's wait until we finish the setting of LANnet loopback to reboot the machine. On border basic LANnet loopback, set as follows: source network in LAN, 192.168.2.0/24 IP of original destination outside, 1.2.3.4 protocol, TCP port number, 80 new destination IP in LAN, 192.168.2.21 and hit the submit button to wait until those changes are submitted. And then, reboot the machine by clicking the icon on the right corner above. Sometimes, you might also reboot your PC if you have existing connection on those machines to clean up those existing connections.